Hi guys, so today what we're going to be doing is very similar to what we've done for double angles and with our sum and difference formulas, except now we're just going to look at the only formula we haven't seen so far, and that's our half angle argument. So what we're going to do here, if you look at this very first one, I'm given an expression and I need to simplify this. So what I'm going to do is I'm going to look on my formula chart and see which expression is similar to the one I have written. So it's the square root of 1/2 times 1 minus the cosine of 4a. And this looks exactly like my sine 1/2 x formula. The only difference is, instead of x, I have 4a. So the way this can simplify is the sine of 1/2 times 4a, which I can simplify. 1/2 times 4 is 2, so that's the same thing as the sine of 2a. And all I had to do was just figure out which formula on my chart does that look like. And again, that's very similar to what we've been doing, just getting used to those new formulas that we have. Then the other one I have on here, again, a similar question to what we've been seeing with half angles. Again, to start here, it tells me that the cosecant of x is -13/5. And then it tells me that x is between pi and 3 pi over 2. So I'm going to draw a picture for this. Remember, again, we are not actually finding the value of x. X is an angle measurement, and since these aren't exact values that we're used to finding, I can't determine this on my own. So what I'm going to do is between pi and 3 pi over 2, which is quadrant 3, I'm going to draw my picture. My hypotenuse is 13, and cosecant is reciprocal of sine, which means my opposite is 5, and that'll be negative based on my picture. If I do Pythagorean theorem, that missing side would be 12, and because of where it is in the picture, it would also be a negative. And x is that angle right there. So what I'm going to do is I'm going to find the cosine of 1/2 x based on this picture. So I look at my chart, cosine of 1/2 x is equal to the square root of 1/2 times 1 plus cosine of x. So in this case, there's only one fraction I need to fill in, and that is the cosine of x. So I can rewrite this now. This is the square root of 1/2 times 1 plus the cosine of x, if I look at my picture, is a -12/13. And then at this point, it's just some math with the fractions, paying attention to order of operations. So I'm going to change 1 to 13/13, so I have a common denominator. Now I can combine those two together. And again, order of operations, I'm doing the parentheses first. So 13 plus -12 is 1/13. I multiply those fractions, so I multiply across the top and across the bottom, so I get the square root of 1/26. Now, if I could simplify this farther, I would. Just remember, when you square root a fraction, that's the same thing as the square root of the top number over the square root of the bottom. And the square root of 1 is just 1. So I could just rewrite this as 1 over the square root of 26. Now the last thing on here I want to pay attention to is if you look on your formula chart, all of these formulas have a plus or minus in front of them. So in order to figure out if this should be positive or negative, I need to go back to what was originally given to me. Okay, so originally it said that x is in between pi and 3 pi over 2. I'm finding the cosine of 1/2 x. So what I need to do is figure out which quadrant 1/2 x would be. So if I divide everything here by 2, if I divide that by 2, I divide this by 2, and I divide this by 2, 1/2 x is going to be between pi over 2 and 3 pi over 4. And pi over 2 and 3 pi over 4 would be right in this range, so in the second quadrant. In the second quadrant, I know that sine is the only function that's positive, so if I'm doing the cosine of 1/2 x, then this function would actually be negative. So it's a -1/26. And that's really it for half angles. It's very similar to what we've been doing with our double angles and our sum and difference formulas. So not a lot of new information, just some different formulas. Again, when it comes to these positives and negatives, just make sure you double check, make sure you know where the 1/2 angle would actually be based on the original given restrictions.